The first of both is like given by Ben Kurtz, and it's called short attention span security, which is like some sort of lightning talk, but like 8 of them, I think.
Yeah.
And he has so many slides, so we will see how much he really managed to do in that time. So say hello to Ben for his talk.
I don't necessarily speak in public that often, so if I have a nervous breakdown or something, or if you have trouble paying attention to me or understanding what I'm saying, I've written up all of the talks that I'm going to go over, and I've put them on a website along with all of the code and links that I'll mention tonight. So if you go to the site awgh.org, it's right up there, I pronounce it og.org. You'll find pretty much all of the content from this talk. So with that said, you can zone out and think about something else. So some of the subjects I'm going to go over right now. I'm going to talk about script injection in Flex. I don't necessarily have a universal solution, but I have a couple of tips that might be helpful. I'm going to talk about EFI, which is the new BIOS framework that's going to become a universal standard over the next year. I'm going to talk about a GCC plugin from Mozilla called Dehydra, which actually makes it possible to write your own static analysis using just JavaScript. So it's open source, it's free, I've had a lot of fun with it, so I'm going to talk about that. And if I have time, I've written some scripts that automate the Aircrack NG toolset that I use on embedded devices just for cracking WEP. That's a little less interesting, so I push it to last. But if you were attracted by the phrase short attention span, you're probably already bored. And being the Christmas season, I've made a toy. So it's my present to you. I hope you like it. It's something that messes with Mailinator. If you don't know what Mailinator is, it's a website that offers anonymous email service. So it's something that you would use if you were signing up for like a torrent tracker or a porn site or something, and you didn't necessarily want to get any spam, so you wouldn't want to give them your real email address. Now, what's a little bit different about Mailinator from other sites that offer anonymous email is that you don't need to go to the Mailinator website before you use it. Any email address any email that's addressed to a Mailinator address or any of Mailinator's aliases, it has several domain aliases like sogetthis.com, thisisnotmyrealemail.com, there's a bunch. But you can just send it an email and then go without doing anything first, and then go collect that email from the website without logging in. There's no users. Every email that goes to the site can be accessed by everybody, although it only will stay up there for an hour or two. So I wrote 2 scripts. Together I call them the Mailinator. But this is just sort of, I was doing a lot of web pen tests, and I was getting sort of increasingly irritated by just how bad most forget password pages are. So I saw a bunch of forget password pages that just ask you for an email address, and they don't forbid people from signing up with Mailinator email addresses. So maybe you can see where this is going already. The other thing that forget password fields never do is they never check for brute forcing, even if the login page checks for brute forcing. Because since the user's unauthenticated, they'd have to ban somebody by IP, where on the login page you can lock a user out. So I think some people sort of get lost in what they would actually have to do. But the first script simply brute forces the forget password field on a list of sites, and tries every email address or every username from a list of usernames combined with all of the aliases from Mailinator. So it'll try Bob at Mailinator and Bob at SoGetThis and Bob and so on, right? So the idea would be that you would point this at some site that you wanted accounts on for some reason, and it would just go through the list. They're probably not looking for this sort of attack. And anytime it gets a hit, it's going to issue an email to Mailinator that will have either a password reset link or sometimes the plain text password, which is a big no-no. And then the second script, which is actually more useful on its own, reads the same user list from a file and then goes out to Mailinator and collects all emails addressed to that user that have the word password. So I did hard code the English word password, which has worked on some Italian sites, but you may want to add a word for your language of choice. This is also fun without using the brute forcing script, just as a cron job, because you can collect password reset emails that you didn't ask for yourself sometimes. So I actually got this idea too. You may have, I don't know if this was covered out here, but one of our vice presidential candidates' Yahoo email address was hacked into by someone exploiting a really bad forget password logic in Yahoo. They asked just really simple security questions: birth date, favorite color, things that were easily guessable or look upable online. The one thing I'd just like to remind everybody: the forget password page exists for the sole purpose of letting people bypass authentication. So you should just sort of be more careful in general. Well, maybe not you specifically, maybe your customers. But, I love Mailinator. I actually use it myself. You do have the option, if you do ask for a password reset link, you can go to the Mailinator site and you can go through a CAPTCHA and you can force it to delete a single email. So if you have an email issued and you go and collect it right away, there's a really small window that someone else's cron job would catch your password. So I didn't want to anger them. I'm not really sure how they make money. It seems to be some sort of experiment in server architectures where they just want to collect a whole bunch of spam and see if their network dies. I have no idea like what they're really up to, but this doesn't appear to violate their terms of service at all because they don't have users, they don't have terms of service. So I just need to add a disclaimer here that if you actually log in using someone else's password and it's not an authorized pen test, this is illegal in every jurisdiction. So just once again, these scripts are available on the website at that link, or you can just go to og.org and all of the files are linked from there. New topic. So there's an urban legend in the security community, and I just say it's a legend because I've never seen this myself, but I've heard a couple of different stories, where you've got a lowly system administrator who notices one day that all network traffic coming off the network card of one of his machines is being duplicated and forwarded to an IP address in a country with no extradition treaty. So thinking there's some sort of malware installed, there's some sort of rootkit, he reformats the hard drive and reinstalls the operating system. Sure enough, when he fires it up again, it's still happening. So people forget that there are more places in the computer that have executable code that can be rewritten than the hard drive. So I'd just like to talk about BIOS rootkits a little bit. Specifically because of EFI, but I'll get to that in a minute. And in the past, because BIOS rootkits and legacy BIOS are notoriously hard to do. I think I've met maybe 2 people lifetime total that could have like successfully written one. There aren't any really pre-made libraries that you can get openly if you don't work for a BIOS company already. So if you want to do network traffic, you have to write a network driver at the lowest level conceivable. And you need to write it in 16-bit mode, which is, I mean, I'm not that, well, it's pretty archaic. So there were a couple other news mentions of other hardware attacks in the news last year, and I think this is going to be a much bigger vector in the future. For example, there were some catalysts sold on eBay that actually had a backdoor rootkit implemented in hardware. And I think they were selling them out of Asia, but I'm actually not sure about that. And then there were a bunch of USB picture frames sold that had the U3 exploit that did auto run and installed malware that way. So in general, there's two ways of delivering a BIOS rootkit. You can flash an additional BIOS module to the BIOS itself. There are some secure chipsets from, there's one from Phoenix and one from Intel that will require BIOS modules be signed, and that can be supported with a TPM, which can hide a private key. But they can also be flashed to PCI option ROMs. So not all PCI cards have these. Usually you'll find them in high-end network cards or high-end video cards. But every PCI card can have a flash chip or a ROM chip that contains executable code. They can contain up to 8 PCI option ROMs, they're called. And what those are used for, normally, when the BIOS starts up, it enumerates all of the PCI devices on the bus, and for each one, it goes out and asks if it has an option ROM. If it does have an option ROM, it copies the contents of the option ROM into memory, and then executes it with ring 0. There's no safeguard or anything, and it has to be executed with ring 0 because what this code is for configuring the chips on the PCI card at the lowest level. So you can't, like once you decide that an option ROM can execute, there's no way of preventing what it can do. So now both of these methods can be done remotely if you've already owned a box and gotten root or admin. There's a way to elevate your privilege from that to the point that you can flash on Windows and Linux. Additionally, some PCI devices can be reflashed over PXE. But I'm not going to go into that. So. Once a BIOS rootkit has been loaded, the BIOS code itself, or most BIOS code, only executes once, which is at boot. So in order to make the rootkit work while the OS is in flight, you need to find a place to hide your code from BIOS where the OS where it can be executed once the OS is running. The two main methods of doing this are to hide it in ACPI machine language, which was a method described by John Heisman in 2 papers in 2006, one of which I would highly recommend is called Implementing a PCI Rootkit. The downside of this approach is that it's easily noticeable because everyone can access the contents of the ACPI hooks. The other method, which shows a lot more promise but isn't as widely understood, even by me, I should point out, is system management mode, which is a feature built into Intel chips and AMD chips, which is kind of like a timeout from the normal functioning of the processor. You send a special instruction, the contents of everything are sort of frozen, and you go into this sort of special maintenance mode where you can assign traps to I/O port reads, and then have so when a particular I/O port is read from, you can assign handler code from BIOS. And this is actually really sneaky because it's pretty difficult for an average user couldn't necessarily open that up and see what's in there. Now, since I've gotten to this conference, I met Peter Stug. of Coreboot, and he really, in the last year and a half, I've been asking random people I meet on the street if they know anything about system management mode. He's the first person that was like, yeah, I know all about system management mode. Not only that, I wrote a library that helps you assign SMM traps, and it's in Coreboot. So if someone was interested in writing an SMM rootkit, I would recommend looking at the Coreboot source. That's definitely what I'm going to be doing. I should also point out that Peter has a workshop downstairs in the basement in the workshop room at 10 o'clock this evening. So maybe I'll see you there. So I mentioned some of the problems that people had writing rootkits in legacy BIOS. Basically, the vast majority of the population decided that it was too much of a pain in the ass to really even bother with. Sorry, this got misplaced, but one additional note on system management mode is that although you can trap PS2 keyboard keystrokes relatively easily by just listening on IO port 80, for USB keyboards, I don't have a good solution for this. I've asked a couple people, and it seems to be a much more complicated problem. So I'd actually just like to throw this out to the audience and see if anybody has an idea of how you could get USB keystrokes from system management mode. And okay, bummer. Legacy BIOS is 16-bit. Nobody likes 16-bit. The ACPI relies on the OS using ACPI, but this actually isn't really much of a problem because almost every OS does these days. So EFI is the new BIOS framework. It was developed by Intel mainly, the main political motivation was just to get away from 16-bit mode. They weren't really motivated by any kind of security concerns at all. The reason I mention this is that the previous thing with the PCI option ROMs, where it just gets loaded from the ROM and then executed with ring 0, is still true in EFI. The EFI also makes life extremely easy because it provides a free development kit and a whole bunch of pre-made C libraries, including a full TCP/IP network stack, PXE drivers, other network functions. There's a DHCP. There's all kinds of stuff. There's also file system drivers available for FAT, NTFS, and ext2 that I know of. Also, the EDK is great. It was supposed to be a totally open framework, and you can't build an entire BIOS out of the EDK, but what you can build using just the freely available source, you can build PCI option ROMs, and you can build single EFI modules, which, as it happens, are the only two things I'm interested in building, so this works out. There's some other, this is kind of, if you wanted to deliver an EFI module rather than do it through a PCI option ROM, there would have to be some element of social engineering. You'd have to convince somebody that they should download something from your site and then run it. This might be a little bit easier because Apple, which has been using EFI for years, some Apple users who wanted to do dual booting or triple booting are already familiar with a tool called Refit, which does flash stuff to EFI. To be lame, that is not as cool as SMM or ACPI, but something that you could easily write using available EFI drivers and just write it in straight C. You could write a rootkit that wasn't quite as sneaky, and instead on startup just actually wrote a hard drive. Every time the machine boot, you could write a hard drive rootkit to disk. Or you could read the SAM or the shadow file and send it out on the network. Probably DNS is better than email. The reason I'm bringing this up now is because not too many people have heard of EFI, and a lot of people have been steering clear of BIOS shenanigans just because they heard it was hard. So Intel has been ramping up on EFI very slowly, but for several years now, and Apple has been on EFI since 2006 for all of the Intel Macs. But this year AMD is also going to be shipping EFI compatible boards by default. So by the end of 2009, I'm not expecting to see really any new legacy BIOS boards in production, except for maybe some embedded stuff. And the other reason I wanted to bring this up is because there's a common misconception that somehow TPMs fix the PCI option ROM attack, and this really isn't so at all. All the TPM is required to do is really just store a private key, which is burnt into the chip. So it would really be up to the BIOS itself to use that key to verify a signature on a PCI option ROM. And you can do that with the BIOS itself because the executable part of the BIOS probably isn't going to change very often. So it's no problem to require that it's signed. But to verify signatures on PCI option ROMs, you would need to have a set of signatures for every possible PCI peripheral you might want to add to your machine, and all versions of their firmware. In the biggest case, you could implement this with. And no, I should point out that no BIOSes I've heard of actually do that kind of checking. You could take a shortcut and just lock down a particular configuration of a machine. Say with certainty that only these brands of PCI cards and only these versions of firmware will be allowed. And then what you could do in an EFI module is you could stop before the PCI option ROMs are loaded, check the signature, and then decide whether or not to execute it. You could do that, but no one is. So one possible solution that occurred to me would be to set up a web of trust system similar to the way SSL certificate signing works, where you could whitelist option ROM firmwares that were known good by some trusted authority, and have a secure repository on the local network where machines, when they started up, they could check in with the repository, verify the signatures of their option ROMs, and then only run verified code. This probably isn't feasible on a large scale, but it might be a good idea for a government installation or like a power plant where the rules of computer use are a bit different than the general population. And in general, I think attacks on TPMs and other security coprocessors are going to be a big deal in the future. You could implement a TPM in hardware with an FPGA and have it just do the functions it's set out to do, but it's not economically viable. Most people use just another processor and a piece of flash that holds that processor's firmware. If you can access the flash chip that holds the security processor firmware, you could consider rooting the security processor. Some of the sort of broader implementations that include a TPM have direct access to memory and also can read and write on the network, among other things. So that's something I see coming down the pipe that I think will be a lot of fun. But here's a 2-slide. This is one of my favorite examples of how a design decision in a library that by itself isn't a bug can contribute to a bug way down the line. So anyone who's used the Microsoft implementation of libxml may have noticed that the end tags aren't empty in the parser. Like when you parse the start tag, and the start tag's got some attributes, and then there's some stuff, and then you go to the end tag. There's no end tag attributes, but if you access the end tag object in the libxml library and use the predicate is empty, you'll get false. It's not empty. In fact, the end tag shows up with the attributes of the start tag. Basically, this just tells me that the start and end tag in Microsoft's libxml are treated as the same object in a object-oriented programming sense. So they share the same attributes, or their attributes get merged. So the last version of the Microsoft anti-cross-site scripting ISAPI filter only triggered on a less than sign followed by a letter. So in the new .NET request validation, they also trigger on a less than sign followed by a question mark and a less than sign followed by a slash. But in the ISAPI filter, this would work. And I just wanted to show this to you because it's my favorite thing ever. So it relies on that weird peculiarity of libxml, only on Microsoft. Then it goes to a CSS style tag, and then it goes back to JavaScript. And that's just sort of a lead-in for talking about script injection in a different target, which is Macromedia's Flex. So Flex is getting really big, and it's a sore point for people that do web app vulnerability testing, because it's really, really hard to find script injections. The reason for this is that the Flex builder gives the user a development environment and a form builder where they can just sort of drag GUI widgets out onto their web page, and those widgets already have sanitization and filtering built in. So you can't sort of rely on finding little developer mistakes. And just sort of beating on it that way just leads to frustration. Another frustrating thing about Flex is that now, when I talk about Flex network communications, I should point out that this isn't set in stone, that all Flex applications will work this way. You can do anything from Flex you can do from Flash, so you could set up any sort of communication with the backend that you wanted to. So I'm just going to talk about a particular kind of generic case. But what happens is that a huge SWF file, like 2 megs, gets sent to the browser, and you can decompile it, and there is nothing in it. It is seriously, it's just layout and fonts and themes and skins, and all it does is it takes in XML back from the backend service, renders it to interface components, and then when a user clicks, it sends an AJAX request back to the backend to get the next batch of XML. So nothing in the SWF file actually does anything. So it'll decompile into a massive quantity of ActionScript that there's really no point in reading. And additionally, like one other irritating thing about Flex is that I've seen a lot of session-based URL scrambling, and this was kind of a new thing for me, where static content on the pages would have the same URL, but anything that you might want to hit that could affect change on the site would be, like things you'd want to hit for a cross-site request forgery attack. Would be given a random URL, which would be assigned uniquely per session, so that every time you logged in, you get a new session ID and the URLs are scrambled. So after login, the SWF presentation layer makes a request to the backend for an XML mapping for the current scrambled URLs. So it maps the action to the correct URL, sorry. But if you think about how you would implement, I mean, it would be very difficult or impossible to implement this system and have a rule where the browser could only request this mapping once. It seems like it would be almost hopelessly prone to failure. So you're allowed to re-request the URL mappings anytime you want to. However, one wrong guess will de-authenticate your session, and you'll have to re-log in, which actually kind of breaks up brute forcing quite well. So in the event you could get script injection in Flex, the first two things you need to do are go out, make an AJAX request to fetch the current URL mapping, and then you need to parse that XML to find the action you want, and then you can construct a URL that will drive the site. I think of it kind of like ASLR for web apps. This is actually a terrible metaphor because guessing repeatedly probably isn't a good idea, because you'd get de-authenticated every time for a wrong guess, and it's a lot easier just to get and parse the XML from JavaScript, in my opinion. Okay, so that's all well and good, but you still need a script injection to do any of that, right? So where do you look for script injection when you're pretty sure that all the inputs are locked down? So one idea, and this ended up working out quite well for me, is you look for browser bugs. So I noticed a bug in IE that I haven't really heard anyone talk much about, but I know I'm not the first person to notice. But when downloading and opening HTML attachments only in Internet Explorer, so this only applies when the content disposition is set to attachment and it's an HTML file. So that is, you're downloading an HTML file instead of opening it in the way that a browser normally opens it. So I'm going to talk about one bug for a couple minutes that would allow you to get a script injection in Flex, but only if it's maybe a group site or something that allows users to upload HTML files. So the bug is that when an HTML file is downloaded in Internet Explorer, if the user opens it instead of saving it and opening it later, if they open it immediately, any script in that HTML file executes as if it was being served as a regular web page from that site, and you can access all that site's cookies. Now, in Firefox 3, they handle this situation better. A downloaded HTML file is treated exactly the same as a locally opened HTML file. Even if you hit open, what it really does under the hood is it saves it and then opens it in a local context. I admit this trick is kind of lame. I'm not trying to tell you that I'm cool. All I'm saying is that this works, and I think it's kind of slick. So I have a... if you didn't really understand anything I just said, I've, oh dear. Well, you can't really see this at all. Here. There we go. Bah. Well, anyway, so the first, you can't see the top, but this is in, this is also on the website. I'll just let it go. So this is in Internet Explorer. You get the option to open, save, or cancel. So if you click open, steal your cookies. And actually, I ran this off my blog, so I accidentally stole some of the WordPress cookies as well. But I set the IE bug, I just stole your cookies from the site. And you can actually try this yourself on og.org/IEbug. And then all the script does is alert document cookies. So then, and next up is in Firefox, just to show the difference. If you do the exact same thing in Firefox, it gives you the open or save option. I go to open, and nothing. Wrong program. So now, according to the IE8 security blog, this has been fixed in IE8. But how they chose to fix it is that they required the server to set a response header. The server has to set a response header called xdownload options, and they need to set it to no open. And that doesn't actually make it behave the same way as Firefox. All that does is it removes the open option. So all you see in that case is you see the option to save or cancel. So call me a pessimist, but I can actually see somebody going back and disabling that option, even if it was enabled by default in Microsoft web servers. I can see somebody turning that off because they got some complaints from their user that the open option went away. Also, just, you know, this is one idea if you need a script injection and there's nothing in the web app. But if you need more ideas, actually, the IE8 security blog, the list of things they fixed in IE8, basically anything that prevents script injection that's new in IE8 is probably a working bug in IE7. And in retrospect, I really wish I had started there, and it would have been easier to find this, I think. So this bug still works as of the latest patch level in IE7. It's probably going to continue to work into IE8, especially if most people forget to set this header. So actually, if you're a site admin, on all of your downloadable files, you should probably set the X download only, or the X download options header to no open, because it also prevents the MIME type inference types of bugs where there's like HTML inside of image files and stuff like that. But I think it's a little bit silly to require a fix on the server side, because I don't think it's going to necessarily occur to like Apache admins that this is something they need to do in order to make IE8 work. And I'm not sure they're going to fix it in IE7 pretty much ever. So I thought it was kind of good to talk about. It's sort of a branch case, but it's something that might be useful. So just to go through the whole process then, you would upload your attack HTML to the site, and then someone downloads it, the script executes. The first thing it does a AJAX request to get the URL mappings, it parses the URL mappings, and then you have credentials on the site and you know what URLs to hit to do stuff. So this is kind of cheating. I've basically just completely avoided Flex. But that's all I got, so. New topic. Now I'm going to talk a little bit about C and C++ code audit. Does this look familiar to anybody? You know, all these great, wonderful tools we've developed in the 21st century, and day one of a code audit when you're like, wow, that's like 600 megabytes of source and I have 5 days to work on it. We'll just grep for str copy, right? Well, okay, so, you know, I'm not knocking grep, I use grep all the time, but I think we can do a little bit better specifically for code audit in terms of tooling. And one thing I've been playing with this year that's actually a whole lot of fun is a GCC plugin developed by Mozilla called GCC Dehydra. And there's also an LLVM version of the same thing, but it's not quite as far along, so I'm not going to talk about that. But basically, this lets you do C and C++ static analysis. You can write your own searches just directly in JavaScript. It uses the SpiderMonkey JavaScript engine. If you hate, I'm skipping ahead, but a lot of people say, well, static analysis, you know, I can prove with math that can't find all bugs, and you're absolutely correct. There's no way that static analysis will be able to find all categories of bugs. So the only thing I'm really recommending it for is that it's slightly better than grep because it lets you do searches on the abstract syntax tree of C++ code rather than searching through strings, which is what grep does. So if you do your search on the parse tree of the program as GCC parsed it, you don't need to worry about white space. You don't need to worry about any of that stuff. It's after lexing, right? So when you're looking for code constructs with grep, you need to build like what the white space could be into the regular expression. And the other cool thing about Dehydra is that it's free. The other option that most people have heard of for static analysis is Coverity. Coverity is expensive, although when I say that doesn't really mean anything because I don't like paying for stuff. But it's also closed source. They sell it as a service, which means I can't see how it works, so I don't know if I can trust it. The projects I've talked to that have used it I've gotten mixed reviews. It's missed some bugs it could have found, some things it's good for, some things it's not. And one selling point of the Dehydra project is that although they don't actually have that much knowledge about security themselves, they're very interested in building this plugin out to support security code auditors. So if you go on their IRC channel and say, I need this feature for security reasons, actually when I did that, they had a patch within 24 hours. So they're like way super helpful. But it's definitely being actively developed. I actually like that it uses JavaScript. It's kind of a toy language. Some people have problems with JavaScript, but it is really nice for tree operations. Basically, if you're moving around the DOM or just moving around the abstract syntax tree, using JavaScript is actually pretty nice. But if you really wanted to, looking at the GCC dHydra plugin, looking where they hooked into the source of GCC to access the data in the abstract syntax tree, it would be very simple to go in and add an interpreter, or add hooks for a different interpreter. Maybe you only use Lisp or Haskell or Erlang or whatever. But I would still recommend looking at this plugin and just how they do the hooks. So the way the plugin works is that it uses a visitor design pattern. So as the compiler traverses each node in the abstract syntax tree, it performs a callback out through the plugin to your user-provided JavaScript. So this is just a simple example of a JavaScript that would that you could use to look for a particular pattern. This is looking for 3 patterns related to assignment. It logs a message anytime a negative number is assigned to an unsigned int, which isn't really a problem usually. But it also flags when you assign a signed data type to an unsigned data type or vice versa. You can also access the bit length of data types, so you can find out when like smaller things are copied into bigger things or vice versa. And you can also do things, and all of those you can get if you just use strict warnings in GCC, so that's not that great. But you can also detect things like calls to malloc where the return value is unchecked, or calls to ASN printf where the return value is unchecked, which would be something that would be really hard to do with grep. So the reason I bring this up is because it would be really, really nice if everybody here that does code audit, like took their set of tips and tricks and codified them as JavaScript files, and then basically life gets much easier for everybody on day 1 of a code audit, which of course means more time for XJump. All right. So I don't know how I'm doing for time. I feel like I've been talking really fast, but we're on the last topic. And this is probably the least cool and least interesting sounding, but in the last year, these are all projects from the last year, this has been probably the most life-altering project in terms of actual usage. So what I did is I built an ITX box, and I wrote some scripts for it that give you a web front end that drives the aircrack tools, okay? And so my hardware setup is just I'm currently using a small ITX box with 2 Wi-Fi cards. One is a good Atheros chipset that I use for monitor mode and reinjection, and the other is just the, I actually connect to it with my iPhone, and I've written a web app that is currently sort of customized for the iPhone, but it's all driven by a single combo box, which looks really good on the phone, but probably not so great in a browser. So I got this idea because I have a room in my house that's full of nothing but tech garbage. It's like the junk pile, and I was bored one day, and I wandered in there and thought, what can I build from stuff I've got? And the other thing is that although academically everybody here knows that they can go out and get aircrack and crack WEP, when you're in a situation where you actually want to do it, you're probably in a hurry, and if you're on a MacBook, you can't do reinjection on these things. Odds are your laptop doesn't have a good chipset for it. It's really just great to have a box on the shelf that solves this problem, right? So it's like if you find yourself needing to crack WEP, you can grab it, go, and you're good. So I highly recommend this. I'm not necessarily going to go into details about how I set up the Gen 2 box or whatever, you know. But I would just like to point out that this has changed my life. I'm one of these people that talks about tech stuff in bars, and that's not a good idea normally. But this one thing, when people are like, "Wait, you have a magic box that can get me on my neighbor's wireless," suddenly everybody's your friend. They're like, "Hey, can you come over?" And it's very surprising. So the advantages now ITX I'm not going to say is like the best thing to use in the future, but it's definitely a viable option. You know, you can get it's pretty big. You're going to end up the smallest ITX case you can get that you can fit a PCI card in is probably yay big. But the advantage of having a PCI slot or a mini PCI slot is that you know for sure you can get a good wireless card. You can look at what Mad Wi-Fi supports or whatever, and then just go buy that. And the other big advantage is that ITX cases commonly come with 12-volt power supplies, so I can just pull up in front of the place I'm interested in, leave the box plugged into the cigarette lighter in my car, and then as I'm walking away, I can start a crack from the phone, and no, I'm not the sketchy guy in the car with the laptop anymore, and that's pretty great. But I'm actually more excited about two other pieces of hardware. I'm going to be porting these scripts to the EEE PC while I'm here, because I actually brought one, and the one I have, I'm not sure if this is true of all of them, but the one I have has a really good Atheros chip, and that's about yay big, so it's actually getting slightly smaller. And but I'm really most excited about the new Atheros AR5315, and that's one of those system on chip boards. So actually, when I told my friend Eric about this project, he said, "Oh, that's nice, but come back to me when it's the size of a deck of playing cards." Dude, the Atheros board is the size of a deck of playing cards. And actually, if you want to see one, I saw one on display at the Open WRT display downstairs. It's #1, but that's about yay big. And the downside of that is that it has an Ethernet port and only one wireless port. So I would probably have to change the script a little bit, but I could log into it on the wireless and maybe launch an attack and then have it shut down and restart and then start the attack. Or maybe you could plug it into your computer, set up the attack, wrap it with something sticky, and then just sort of walk by and stick it to a wall, you know. And that could work too. So I'm looking forward to playing with that a little bit in the future. So another feature of the script, which is kind of important, I think, for usability. Well, okay. So actually, what it's made of, it's getting Mad Wi-Fi and Aircrack NG to work well and drive them from. I'm driving them from Python. But oh boy, Aircrack NG was not written to be Linux command line friendly. Some of the tools give you output in like curses, or you can't use expect on them easily. Sometimes Aircrack says key found and it's all zeros. And it's really kind of confounding. But I've actually sort of, now there's definitely some bugs in these scripts, and like all my scripts. But I've definitely worked out a way that works to automate these. I think that if you use the code, or if you look through the code, you might see some things, especially in one of the bash scripts, where you may wonder what's going on there. But once I got into a configuration that worked, I just sort of left it. So I've been trying to clean it up a bit and port it to different platforms. So if you keep an eye on the site in the next week or so, there'll be some developments there. And the other thing is that I'm driving screen sessions from Python using the subprocess module. So I fire up each of the Aircrack tools. I fire up the dump in a screen session, and I fire up a faked authentication and an ARP replay attack in a screen session, and then I fire up the crack in a screen session. So you can log back in through the web interface and check on the status of each of those screens. It'll actually take a copy of the current state of the screen and show it through the web interface. And if you were interested in driving some other sort of shell scripts with a really simple TurboGears-based Python web interface, this would be a really good sample code to look at. And basically, I kept thinking that the Aircrack project, I thought for a while that the Aerolib thing that they promised was going to come out was like going to do this somehow. And then when it finally did come out, it did something slightly different. So I got impatient waiting for someone to write a good one, and then I just wrote a really, really nasty hack that works. So just in general, my ITX box is a really kind of crappy Cyrix C3 processor, and using PTW, if you're close enough for ARP replay, it cracks a WebKey in 2.5 minutes. So yeah, you don't really need much of a processor, I guess is the point. And if you look at the sample code, it's not skinned at all, but it's a TurboGears web interface, so it would be really easy to add whatever graphics you want. And something else I'd like to add to this in the future is man-in-the-middle attack automation and a rogue AP mode. And that's actually something that it would be really useful to have two Wi-Fi cards for, right? Because you'd want one to connect to the real internet and then one to get people to associate with. And I'm all done. Actually, is that early? No. So I do have one other toy I could show off. I don't normally talk this fast, so I'm blaming the mate. But I do. Where'd that go? I have been playing with a bit of a pattern matching hex editor that uses the sequitur algorithm to detect common substrings in binary files. However, after playing with this for a while, I've decided that sequitur actually really isn't very good for this, so I decided not to talk about it. But that said, does anyone have any questions, or?
Hi, Peter here from Coreboot. Thanks for bringing up the BIOS rootkit topic. I think it's really a big deal. We've been sort of trying to push this to governments and large companies for quite a while, and I think they're finally starting to realize the risks. Also, I can tell you that the urban legend is very much a reality. There is a BIOS vendor that had a similar rootkit, and they got, I think, 5 million users before they shut it down.
Wow.
Yeah, and this was some 5 years ago.
So by the way,
it's very much real.
Everybody, that's Peter from Coreboot, so he's the answer man for all of your system management mode related questions.
Yeah, and also, well, system management mode. I've been poking around the AMD code quite a lot, but I want to say I can't take credit for the other implementation that we have in Coreboot. That was all written by Stefan Reinauer for the Intel platform. But it's really nice. The AMD code was written for Microsoft tools that are normally used to develop BIOS software, but they also have started work on getting that code to build with GNU tools.
Cool.
And it's all open source, so come have a look at it.
Thank you.